Hi, my name is Kennedy Thorne, and this is Lab 1. For Lab 1, it asks us to find an object traveling in motion at a constant velocity, which means it's traveling in the same direction at the same speed. It focused on the relationship of velocity in terms of change of position and time, and we had to record a video of an everyday object moving at a constant velocity, and we used Tracker to track the position change over time and gather data, and using that data to find the velocity, along with using GlowScript to code the relationship and find the computational data. Here is my video of the longboard moving across the room. As you can see from the red dots, that is me tracking the position of the center of the longboard as it moves from one side of the room to the other. And you can also note that the longboard was 1.1 meters long. You can also see the axes as it is set up as the longboard is moving in the positive X direction. Here is the initial position of the longboard at 0 seconds. This is the longboard at the final position at time equals 1.833 seconds as the longboard has already moved across the screen. Using what we got from Tracker, we can see on the y-axis the position change in meters over the time change in seconds of the longboard. Since it is a linear relationship, that means that the object traveled at a constant velocity. Since it is also a positive slope, it showed that the object moved in the same direction, in the positive X direction. If I had chosen the axes to be opposite or switched, then it would show a negative linear slope. Ultimately, it's very important to note that the linearity means that it was a constant velocity, and the positive slope means that it moved in the same positive direction. Newton's second law, which is the force acting on an object is equal to the mass of the object times its acceleration, which can be shown in the two formulas below, is very important because zero acceleration means no forces are acting on the object. So if the object is moving, like the longboard is, it keeps going at the same speed in the same direction until the acceleration becomes a non-zero value. Using the data we got from Tracker, we can calculate the velocity using a simple formula. The average velocity equals the change of position over the change of time. Therefore, we need to know the object's initial position, which is 0.117, and the object's ending position, which was 1.826 meters. And then we also calculate how long this took, which ended up being 1.833 seconds. So plugging all those values into the formula, we get the average velocity is 0.93235 meters per second. And it is positive because the board moved in a positive direction. Here's my code from GlowScript where I had to change a few things such as the mass and positions and times to accurately fit my video, along with the formulas to accurately calculate velocity and position change. You can see the data graphed out on the right, along with the illustration of the ball moving. On the left, we have the Tracker graph, and on the right, we have the GlowScript, which is the gathered versus the computational data. It is very important to note that both are positive linear relationships, meaning that they both have constant velocities. However, the velocities are different due to different slopes, and this is due to the fact of human error in Tracker, along with the fact that in real world we can't actually have no net forces. Here we have a graph of velocity over time, and this just shows that velocity is constant over time due to the horizontal straight line. Overall, we saw that the longboard moved at a constant velocity due to no net forces acting on it, due to some relationships such as Newton's second law and acceleration and forces. We also saw that velocity equals displacement over time. Thank you.